By the end of the 19th century, scientists have already discovered 83 chemical elements. The smallest and lightest of these elements was hydrogen. Atoms are extremely small. The diameter of a hydrogen atom is about 1 billion times smaller than the diameter of an apple. If we expanded the hydrogen atom to be the size of an apple, in order to maintain the size ratio, we would have to expand the apple to be the size of the Earth. In terms of mass, a hydrogen atom is about 60 septillion times lighter than an atom. A septillion is 1 followed by 24 zeros, the number you would get by multiplying 1 billion by 1 billion and then multiplying the result by 1,000,000. So a hydrogen atom is very light, and it was assumed that there is nothing smaller or lighter than it. In 1897, the English scientist J.J. Thomson was studying cathode rays. If you take a sealed glass tube, pump out the air to create a vacuum, place 2 metal electrodes inside the tube and apply an electric voltage, you will see that the glass behind one of the electrodes will start to glow. This phenomenon was used in old CRT television sets and computer monitors. CRT stands for cathode ray tube. J.J. Thomson wanted to understand what these so-called cathode rays really were. He discovered that the ray consisted of a stream of particles moving from one electrode to the other. What most surprised him was that the particles were more than 1,000 times lighter than a hydrogen atom. After carefully checking his results, J.J. Thomson concluded that he had discovered a new particle that was a lot smaller than the smallest known atom. What's more, this particle could not be an atom itself because it had an electric charge. Electric charge is a fundamental property of matter that is responsible for electric and magnetic interactions. We know that every object has a mass. Mass is the property that characterizes how strongly the object experiences gravity. Heavier objects experience a stronger gravitational pull from the Earth than lighter objects. Similarly, some but not all objects have another property called the electric charge. It characterizes how strongly the objects are pulled by electric fields. The study of electricity is the domain of physics, not chemistry, so we will not be talking about what electric fields and forces are here. It should be enough to say that they are responsible, for instance, for a balloon sticking to the ceiling after it had been rubbed on hair, as shown in the following video.
I can make it stick onto the roof just by rubbing it on my head to create static electricity. Then you just push it onto the roof.
Gravitational forces are always attractive. That is, any object pulls any other object towards itself, with a force that gets stronger as the masses of the two objects get larger. That is why all objects fall onto the ground. The Earth has a very large mass and is pulling everything towards itself. Unlike gravitational forces, electric forces can be attractive or repulsive. That is because there are 2 types of electric charges. These 2 types of charges are called positive and negative. If you take 2 objects that have electric charges of the same type, either 2 positive charges or 2 negative charges, they will push each other apart or repel. If you take 2 objects that have electric charges of different types, one positive and one negative, they will pull each other together or attract. This observation is the origin of the statement that opposites attract. Atoms do not have an electric charge, but the new light particle that J.J. Thomson discovered had a negative electric charge. This particle is now called an electron.